Artemis II, humanity's return to deep space. For over 50 years, humans have remained close to home. We've orbited Earth, built space stations, conducted thousands of experiments in microgravity. But we haven't left. We haven't ventured beyond low Earth orbit, haven't traveled farther than a few hundred miles from the surface. The last time humans left Earth's immediate vicinity was December 1972, Apollo 17. 3 astronauts traveled to the moon, spent 3 days on the surface, and returned. Since then, no human has gone farther than the International Space Station. That's about to change. Artemis II is not just another space mission. It's the first step in humanity's return to deep space, the first crewed mission beyond Earth orbit in over half a century, and the beginning of a sustained presence on the moon that will eventually take us to Mars. This is not Apollo. This is not a repeat. This is something new, something more permanent, and it starts with 4 astronauts, a spacecraft designed for deep space, and a journey that will test everything we've learned since we last left Earth behind. Artemis II is the second mission in NASA's Artemis program. Artemis I, launched in November 2022, was uncrewed, a test flight. The goal was to validate the Space Launch System, the most powerful rocket ever built, and the Orion spacecraft, the capsule designed to carry humans beyond low Earth orbit. Artemis I flew around the moon, tested Orion's heat shield during re-entry, and demonstrated that the systems work. Artemis II takes the next step. It puts humans aboard. 4 astronauts will launch from Kennedy Space Center in Florida, atop the Space Launch System. They'll travel farther from Earth than any human has traveled since 1972. They'll loop around the moon, not landing, but passing within a few dozen miles of the lunar surface. Then they'll return home. The mission will last approximately 10 days. This might sound simple, a flyby, no landing, no moonwalks. But Artemis II is critical, because before we can land humans on the moon again, we need to prove we can get them there and back safely. We need to test life support systems in deep space, navigation, communication, radiation exposure, emergency procedures. Everything that could go wrong on a mission to the lunar surface needs to be tested first on a mission that doesn't land. Artemis II is that test, a shakedown cruise, a verification that the systems work with humans aboard. And if it succeeds, it paves the way for Artemis III, the mission that will land the first woman and the first person of color on the moon. The spacecraft is called Orion, and it's unlike anything that's flown before. Orion is larger than the Apollo command module. It can carry up to 6 astronauts, though Artemis II will carry 4. The crew module is pressurized, providing living space for the astronauts during the mission. But unlike Apollo, Orion is designed for longer missions. It has more storage, better life support, advanced avionics, digital displays, computers thousands of times more powerful than those used during Apollo. Attached to the crew module is the European Service Module, built by the European Space Agency. This is the powerhouse of the spacecraft. It provides propulsion, electrical power, thermal control, and water and air for the crew. Solar arrays extend from the service module, generating enough electricity to power the spacecraft's systems and recharge batteries. The service module also carries the main engine and smaller thrusters for maneuvering. Orion is built for deep space. It has radiation shielding, redundant systems, abort capabilities at every stage of flight. If something goes wrong during launch, Orion can separate from the rocket and return the crew safely to Earth. If something goes wrong in space, the crew can initiate an emergency return trajectory. The spacecraft is designed with safety as the primary concern. Because deep space is unforgiving, there's no quick rescue, no nearby space station to dock with. Once you leave Earth orbit, you're on your own. And then there's the heat shield. When Orion returns from the moon, it will be traveling at approximately 25,000 miles per hour. That's nearly 32 times the speed of sound. When it hits Earth's atmosphere, friction will heat the exterior to around 5,000 degrees Fahrenheit, hot enough to melt steel. The heat shield, made of a material called avcoat, is designed to ablate, to slowly burn away, carrying heat with it, protecting the crew module and the astronauts inside. Artemis I tested this heat shield. It worked. But Artemis II will be the first time humans are behind it, trusting their lives to a system that must perform flawlessly. The crew of Artemis II consists of 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and mission specialist Jeremy Hansen, a Canadian Space Agency astronaut. This will be the first time a non-American travels beyond low Earth orbit. Reed Wiseman is a former naval aviator and test pilot. He's flown on the International Space Station, conducted spacewalks. He brings experience in spaceflight operations and leadership. Victor Glover is also a naval aviator. He flew on SpaceX's Crew 1 mission to the ISS. He'll be the first person of color to travel beyond low Earth orbit. Christina Koch holds the record for the longest single spaceflight by a woman, 328 days aboard the ISS. She's conducted multiple spacewalks and has extensive experience with spacecraft systems. Jeremy Hansen is a fighter pilot with the Royal Canadian Air Force. Though he hasn't flown in space yet, he's trained extensively and represents international collaboration in space exploration. These 4 will be the first humans to leave Earth's protective embrace in over 50 years. They'll experience something fewer than 30 people have ever experienced: the view of Earth from deep space, a perspective that changes how you see the world, how you see humanity. Astronauts who have been to the moon describe it as profound, overwhelming, seeing Earth as a fragile blue sphere suspended in the blackness of space. No borders visible, no divisions, just one planet, home. Artemis II differs from Apollo in fundamental ways. Apollo was a sprint, a race. The goal was to get to the moon before the Soviet Union, to plant a flag, to win, and it succeeded. 12 astronauts walked on the lunar surface between 1969 and 1972. They conducted experiments, collected samples, explored, and then we left. And we didn't go back. Artemis is not a sprint, it's a marathon. The goal is not just to visit the moon, it's to stay, to build infrastructure, to establish a permanent human presence. Artemis III will land near the lunar South Pole, a region that's never been explored by humans. Future missions will construct the Lunar Gateway, a small space station in orbit around the moon, a staging point for lunar surface missions and, eventually, missions to Mars. Artemis is also international. Apollo was American. Artemis involves partnerships with the European Space Agency, the Canadian Space Agency, the Japan Aerospace Exploration Agency, and private companies like SpaceX. The Lunar Gateway will be built collaboratively. Lunar landers will be developed by commercial partners. This is exploration as a collective effort, not one nation, humanity. And Artemis is sustainable. Apollo ended because it was too expensive, too risky, too dependent on custom-built hardware that couldn't be reused. Artemis is designed differently. The Space Launch System is powerful but expensive. Future missions may use commercial heavy-lift rockets. The Lunar Gateway will serve multiple missions, reducing costs. Lunar landers will be reusable. The goal is to make moon missions routine, affordable, repeatable. But why go back to the moon at all? We've been there. We've collected samples. We know what it's made of. Why return? Because the moon is not just a destination. It's a proving ground, a testing site for the technologies and techniques we'll need to go to Mars. Mars is farther, colder, more hostile. A mission to Mars will take years. Astronauts will be isolated, exposed to radiation, unable to return quickly if something goes wrong. Before we send humans to Mars, we need to know we can keep them alive in deep space for extended periods. The moon provides that testing ground. It's close enough that we can resupply missions, rescue astronauts if needed, but it's far enough that it presents real challenges. Communication delays, radiation exposure, isolation, resource utilization. If we can build habitats on the moon, extract water from lunar ice, produce oxygen from lunar regolith, then we'll have the knowledge to do the same on Mars. The moon also offers resources. Water ice exists in permanently shadowed craters near the poles. This water can be split into hydrogen and oxygen. Oxygen for breathing, hydrogen and oxygen for rocket fuel. A lunar base could serve as a refueling station for missions deeper into the solar system. Launching from the moon requires less energy than launching from Earth, because the moon's gravity is weaker and there's no atmosphere. Fuel produced on the moon could enable missions that would be impossible if all fuel had to be launched from Earth. And there's science. The moon's far side is shielded from Earth's radio noise. It's the quietest place in the inner solar system. A radio telescope on the far side could detect signals impossible to observe from Earth. Ancient signals, the faint whispers of the early universe. The moon's geology preserves a record of the solar system's history, impact craters billions of years old, samples that can tell us about the conditions when Earth was young. But beyond the practical reasons, there's something deeper, something harder to quantify. Humans are explorers. We've always pushed boundaries, crossed oceans, climbed mountains, ventured into the unknown. Space is the ultimate frontier. And if we stop exploring, if we remain confined to low Earth orbit indefinitely, we lose something essential: the drive to go farther, to see what's beyond the horizon. Artemis II represents the resumption of that drive. After 50 years, we're going back. Not because it's easy, not because it's safe, but because it's necessary. Because the future of humanity may depend on becoming a spacefaring species. And that future begins with the moon. The risks are real. Space is hostile. Vacuum, radiation, extreme temperatures, equipment can fail, systems can malfunction. During Apollo, we lost 3 astronauts in a fire on the launch pad. Apollo 13 nearly ended in disaster when an oxygen tank exploded. The crew survived through ingenuity and luck. Artemis missions face similar risks. The Space Launch System is powerful but complex. Orion is sophisticated but new. Deep space is farther from help than low Earth orbit. NASA has learned from past mistakes. Safety reviews, redundant systems, extensive testing, but risk cannot be eliminated. The 4 astronauts on Artemis II know this. They've accepted it. They're willing to go because they understand what's at stake. This mission is bigger than them. It's about humanity's future. Launch is currently targeted for 2025, though schedules in spaceflight are always subject to change. When it happens, it will be watched by millions. People around the world will see the Space Launch System rise from the pad, the most powerful rocket ever flown. 8.8 million pounds of thrust, a column of fire and sound lifting 4 humans toward the moon. 90 minutes after launch, Orion will separate from the upper stage and begin its journey. The crew will conduct systems checks, deploy solar arrays, settle into the rhythm of spaceflight, and then, about 3 days into the mission, they'll reach the moon. They won't land. Artemis II is a flyby, but they'll pass close, within a few dozen miles of the surface, close enough to see craters, mountains, the desolate plains where Apollo astronauts once walked. They'll photograph the surface, test navigation systems, verify that Orion can operate in the lunar environment, and then they'll loop around the far side. For a brief period, they'll be out of contact with Earth, blocked by the moon itself, alone. The only humans in existence who cannot communicate with home. This is what deep space feels like. Isolation, distance. The realization that Earth is no longer the ground beneath your feet. It's a distant blue marble, fragile, beautiful, far away. When they emerge from behind the moon, communication will resume. The trajectory will slingshot them back toward Earth. The return journey will take several days. Time to rest, reflect, prepare for re-entry. And then, as they approach Earth, the heat shield will do its job. Friction will slow the spacecraft. Parachutes will deploy, and Orion will splash down in the Pacific Ocean, where recovery teams will be waiting. If everything goes as planned, the crew will step out of the capsule healthy. Mission accomplished. Systems validated. The path to Artemis III cleared. And if it doesn't, if something goes wrong, that's the nature of exploration. We test, we learn, we adapt. Apollo had failures. So did the Space Shuttle program. So did the early days of the ESS. But we persisted, because the alternative is stagnation. Staying on Earth forever. Never reaching beyond our atmosphere. Never becoming more than we are. Artemis II is not the end. It's the beginning. The first step in a long journey. A journey that will take us back to the moon, then to Mars, and eventually farther, to the asteroids. the moons of Jupiter and Saturn, maybe one day to other star systems. But it starts here, with 4 astronauts, a spacecraft, and the willingness to leave Earth behind, to venture into the unknown, to explore, because that's what humans do. We explore, we push boundaries, we go farther, and Artemis II is the moment we start going farther again. After 50 years of staying close to home, we're finally ready to leave, to return to deep space, to remember what it feels like to be explorers. The countdown will begin, the rocket will ignite, and 4 humans will rise into the sky, bound for the moon, not to stay, not yet, but to prove we can get there. And that proof will open the door to everything that comes next. Artemis II is humanity's return to deep space, and the future begins now.